people still need 411? Raise your hand if you don't have it yet. All right, well, William, you're going to luck out. And, well, no, I'll print 2 copies of page 1 is what I'll do. Would you, William, run to the printer on the right out there in the family room and grab the 2 pages that are probably coming out of it? That should be coming out of it. Thank you, dude. Your Chapter 4 math notes I will pass out in a minute, like once we get started. If you want a ruler, get that. If you want colored pencils, get that. And for the love of all things good, and whatever's left of my sanity, would you please turn in your homework? You're making me start to think I need to go back to the, like, every 2 days we turn in a homework, but that's annoying, and I feel like it spends more class time than we need. So if you have yet to, and guys, if you were absent, like, it's not marked timeliness, it's just marked missing to tell you, hey, I need your homework. But, like, please turn in your homework. It's up on the dry erase board what I need. 333 and closure are optional. You can turn those in if you want. You don't have to. I'm going to clear the ink real quick because I forgot to open the right thing. On your dot paper, actually, anyone feel like reading? You should probably read first. Liam, go ahead and hit us with this whole paragraph.
Today, you will extend your study of ratios by looking at margins, reductions of geometric figures. Think of a copy machine and what it does to a picture when the enlargement button is selected. The machine makes every length of the picture larger or smaller by multiplying it by the same number, called the multiplier. That multiplier is also called the scale factor.
So a fun thing about being a teacher is the copy machine. And I'm not joking. Like, sometimes it's annoying. But, like, when you start to change sizes or stretch things or change, like, darknesses or shading or whatever, it's kind of fun. So what we're going to do today is practice manually being a copy machine. Right? Because, you know, back in the day, there weren't fancy pants copy machines. We had to do it all manually. So on your paper, definitely different, on your paper, draw this shape that Karen has at, like, the top left here. But be careful. If you start at the very top left dot, you won't have enough space to get that top little... This is kind of like the Tetris piece, just with the corner cut off of it. Right, so I'm going to scooch this over so we can see both. Now, how long things are, we're going to count by the gaps between the dots. Right, the gaps between the dots. So my left side there, we're going to call that 1. Right, the bottom, how long is the bottom? 2. And then I want you and your partner to enlarge this by 300%. You're going to be the copy machine. You want to enlarge this by 300%. Whoa! You're acting like you need me. You don't need me. 300%. If you order one pizza and 300% of what you ordered shows up at your house, how many pizzas did they bring you? So 300%. Guys, what does percent mean? Out of 100. So 300 over 100. Caleb, you hold your hand up.
So that would equal 3.
That would equal 3. So really what I need to do to this shape is times each piece of it by 3. So this edge that was 1, how big is that going to become? 3. So guys, I would like just draw a little arrow or something. And guys, let's get in a little habit of the shape we start with. Let's make this our 100%. So now we're going to enlarge it by 300%. Or really what Caleb just said is do times 3. So what? Now, I'm not going to start at the top because then I won't have space. So I'm going to give myself a little bit of space and then start. My 1 should turn into a 3. You can go and label your edges. Nice. See how quickly you went from I don't know what I'm doing to I got this? I did it. I did it. Our bottom of 2 will turn into some of my people that really like drawing shapes might be mad that we've been using graph paper instead of dot paper. Now wait a minute. What do we call like slanty lines like this? Starts with a D. Diagonal, right? This diagonal. The diagonal between the dots. The dotty diagonal. How long is that? If you measured the distance between the dots and then the distance between the diagonal dots, it's not the same. That distance, if you really want to know, is actually radical 2. But don't write that down. I mean, you can write that if you want. Yeah, radical, right? Radical, dude. So radical is another way to say square root. But we're just going to call it 1 diagonal. We're going to keep your life real, not E-word. We're going to keep your life simpler for now. So our 1 diagonal is going to turn into 3 diagonal. That's what happens when you don't give your brain time to think. So now I have 1, 2, 3 diagonals. This makes sense. So this is our 300%. What if you did it and did it correctly? What? What? Oh, the radical 2? That's like, you can write that if you want, but you guys don't know what that is yet. It's approximately 1.4. Then it would be 1.4 times 3, whatever that is. But it's approximate. Because radical 2, guys, that actual length is a bad number. That actual, and I don't mean like the E word. Like, this number never stops. It never repeats. It's what we call an irrational number. It's not a good number. That's why I'm saying don't get stuck on this. We're just going to call it 1 diagonal. Try that again, except now what we want to do is take this shape and we want to make a new one that is 50%. And I'm going to pass out your notes. We want a new one that is 50. So draw the original. Draw the original first. I keep doing this. I put the notes up here and I keep walking back there. Extra exercise. Don't put these away yet. You're very well. Do not put these away yet. You're probably going to want a highlighter or 2 or 3. How long is this? The left edge. 4. Right? So ask yourself that first. Did you make that 4? Oh, hey, sunshine. Did you already find your math binder in here? Is it sitting back here where Mr. Smith brought your math binder in to me? And I was like, or Mr. Combs actually. I said, well, I have him this morning. Aha. Where you left it? It's real important when I start saying put this in your binder. You don't want 2 sets of it. You just want 1 set. And that's gonna be a really big shape. So let's take a moment and look at these notes. So pause on your drawings. Let's just start leafing through our notes. Let's see what's here. And some of you are probably going to be a little mad. Because question 1 of the last mastery would have been a whole lot easier if you had the typed out right in front of you commutative property, associative property. However, that was on purpose, guys. Like, if you chose not to write down the notes during class, you made that choice, right? We watched a video. I suggested you write some things down. And if you chose not to, I hope you learned something out of that. Of like, man, I took the easy way out, but then I made things harder. Like, because I was able to use my notes, but if I didn't take any notes, I don't have anything to use. So, now in this chapter, I got it written out for you and some examples shown out for you in your notes packet. But you know what that means is we're going to keep learning even more new stuff. And if you choose to not engage and you choose to not write it down, you're again going to have this moment of struggle on the mastery. And maybe if you are at least a critical thinker, will realize, crap, I had a chance to make this easier. And I either did do it, hopefully, or crap, I didn't do it. So right here, I would highlight those. You know, just a suggestion, though. You make whatever choice you want to make. We'll also come back and talk about distributive property at some point. But I'm going to flip to the back of this front page. And we're going to look at similarity and scale factor. Because that is what we're doing in this chapter. So if you choose not to write this stuff down, that's the choice you're making. If you choose not to write down what I have written, your choice. SF is how we abbreviate scale factor. SF is how we abbreviate scale factor. You don't have to match my colors, guys. I see those of you fighting over orange. Like, it's cute that you want yours to look just like mine. I appreciate that. But it doesn't have to. Now, the book likes to say copy over original. But I don't like to use copy over original because in my brain, copy is the same size. Because when I go to the copy machine and I make a copy, it's like I go to the machine, I put this in the machine, and I get out like 80 of them. Right? Same size, whole sheet of paper. Like, that's a copy in my brain. When I change something's size, I think that is new. Right? So to find a scale factor, you could either put copy over original, or what I like to say is new over original. And I hope that at this point, like 12 weeks into the school year, like you trust that if I like suggest something, I really do have your best interest at heart. Like I'm trying to make your life easier. Your life is hard enough already.
A lot different instead of writing O-R-I-G, writing O-G. Yeah.
So the trick here comes down to one little very important word. Corresponding. If I, time and place, if I look at the 10 and tell you to match it up with 45, why would that be silly? Who can give me like a justifiable, hey, that doesn't make sense and here's the reasoning. I mean, obviously we can see based off how these triangles are sitting, but they aren't always sitting the same direction. Sammy?
Maybe because 10 is on like the straight up and down side and then 45 is on the side.
But I could turn this. I could pick it up, turn it, flip it, do whatever. So you're right with how this looks, but this won't always look like this. They won't always be positioned. Guys, 10, 16, 18. 10 is my smallest, right? 10 is my smallest. 25, 40, 45. 25 is my smallest. I'm comparing the short leg to the short leg. If I want to compare the long leg, trapdoor, in a right triangle, we call this our long leg, the bottom part, which if you want to highlight with a different color, And then you can come over here and 40 over 16. That's our long leg. What's the other side of the right triangle called? Starts with the root that means under. Under. Or below. Maybe it's below then. I thought it was under. Hypo. Hypotenuse. That's our hypotenuse. Oh, you haven't had hypo yet? Yeah, hypothermia, when your body temp is too low. It's under. So the hypotenuse is named that because it is under the right angle. No. Hypo, like hypothermia. Hypo, like hypoglycemic. Hypo, like it means under, like too low, under. So guys, we're going to practice this in a second. And if you don't listen, you won't know what you're doing. In order for these shapes to be similar, every pair of corresponding sides must have the same ratio. So that ratio, 5 over 2, 5 over 2, 5 over 2, when we simplify them down, that ratio has to match the entire shape around. If one of them doesn't match, like guys, if this was 50 instead of 45, it would break. Because 50 over 18 does not become 5 over 2. They would not be similar. They might look the same, but is everything that looks the same actually like a scaled up version? No. All because it looks the same does not mean it is similar. Now wait, what does similar mean? Same shape, different size, right? So up here I would probably highlight similar, same shape. Now I like to say same shape, different size, but actually they could be the same size. Shapes that are actually copies are also called similar. And we say they have a scale factor of, what would be the scale factor if your shapes were identical to each other? What would you be multiplying by? What can you multiply by to get the same thing? 1, right? Your scale factor, if you're making an actual copy, your scale factor would be 1. All right, now that we highlighted some notes, let's look at what we got here. Hi? Yeah. Anyone want to share theirs? Caleb, because you're quick to get up here. Bring yours up real quick. Hopefully, and this is just because I spent so long doing other stuff and passing things out. So Caleb was going 50%. And he went from 4 to 2, from 2 to 1, 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 and 4 to 2. And then what did we say we're going to call this edge? 2 diagonal, right? 2 diagonal turns into 1 diagonal. Absolutely. Good work, Caleb. Yeah, what's up, Xavier?
So I did my thing, like, instead of, like, he had, like, his 1 over.
Yeah.
I made my first one, like, 2 over. Is that okay?
Let me come check what you got. 4-3. I goofed up, and it didn't get copied into here. That's why there's books in front of you. Because I want to start occasionally making it so that you guys don't have to wait for me. So if your book for some reason got closed, you want to go to page 188. You've got the shape for 4-3 in your book right there. Put that in your dot space and do what it asks. Yeah. So the directions, I think what happened initially is you make this one too big. If this is supposed to be your original, no, it's not. This is 150%. You increased by an extra 50%.
of the original. If you order a pizza and I bring you 50% of what you ordered, do you get a whole pizza? So you were thinking 150%. You did extra 50%. We want only 50%, so it should get smaller. Now here's the thing. You don't need to erase this one. You can just draw the correct smaller one inside of it if you want. Like you can use this space inside this shape to draw what that would look like, reduced, right? Because it's going to reduce, it's going to get smaller. What do you mean? So exactly what Caleb had, yeah, so it'd be 1, but I would actually probably shift down a little bit because it's going to be like the 1, 1, 1, 1, 1 stair step, right? And then 1, 2, 2. Yeah, because this was our original, right? If you look in the book, that was our original. Also, those of us that are visually impaired, what? What don't you get? So, to review again, because I can tell from walking around, a couple of us are struggling, and probably more than a couple of us. This shape that we had, I'm going to draw real quick. 4, 2, 2, 2, 2, 2, 2. All right. This shape is our original. You should probably label this 100% if you are struggling. Guys, I'm back on 4-2. I'm redoing this problem. If you are moving on, that's fine. You even have a book that you can move on with. But for anyone that wants to go over 4-2, listen and watch. We want to make a quote-unquote copy that is 50% of this shape. Not 50% bigger, but just 50%. So to make a new shape that is 50% of the original, that's really like multiplying by a half. You can also divide by 2, because that's the same thing as multiplying by a half. So my edge that was 4 now becomes 2. My stair-step edges that were 2 now become 1, 1, 1, 1, 1, 1. My bottom that was 4 is 2. My 2 diagonal is now 1 diagonal. And this is 50% of the original. Does that make more sense? Everything is, and actually, guys, if we draw it inside of it, it would kind of help us see it. So if you want to, go back and draw this inside of here. So now, with 4-3, you actually get to be a little creative. So this is what you should be looking at in your book. It lets you do what you want. If you haven't done 4-3 yet, do it. It lets you do what you want. It's in your book. Yeah, you times by 2, that is 200%. This diagonal is different. Yeah, you're right. But I'd be curious, what happens if we make it bigger? Does it end up on any dots?
Yes and no.
Why might you avoid making it smaller?
Because then it would be
Careful. If we're taking this shape and enlarging it, I think that needs to get bigger. Yeah, every piece needs to get bigger, right?
Yeah, one wouldn't make sense.
Do I have space? If you haven't done it yet, 1, 2, 3, 4, 5, 6. Ooh, I have just enough space. And then, how wide is it?
4.
3. Careful, guys. You're not counting dots, you're counting spaces. 4 dots is a length of 3. The top was 1,
The right side was 3. And then this diagonal is kind of a pain in the butt, which is why I said get a ruler. Anyone want to give me an idea of what you scaled by, Emily?
Okay. So, you actually have to go into the decimals and halves, which make it not exactly on the dot when you're reversing.
I'm going to stop you just because you said have to. You do not have to do anything. So take that back real quick. Restart. What did you do?
So, what I did is I reduced it by 50%.
So I'm going to go this direction to make it smaller because I'm going to keep this side to get bigger. So if Emily did 50%, what is Emily really multiplying by?
500.
Half or 0.5. Or, like Grace said, we could also divide by 2. Right? To get 50%, you actually divide by 2. So this 6 becomes 3. The 3 becomes 1.5. So this is where Emily was talking about needing to use decimals. Crap. And then my 1 top becomes a half. And now my diagonals still need to connect, and they're still a pain. Boom. Guys, by the way, thank you. Like, you're awesome. And, like, my morning, and I had a sub in here during 1A, and, like, he was just in the back, like, kind of, he looked confused. Because, y'all, like, when I stop talking, nothing happens. Which is not the case at every school. It's like, thank you. Y'all are awesome. Now, the flip side of that is if this is confusing, you gotta speak up. Because Emily made the choice that I wouldn't have made because I don't like decimals. I think I've said this before. I'm going to avoid decimals, so I'm probably going to avoid getting smaller. What's my alternative option? Get bigger. So if we do, now, what times 2, what percent is that? 200. So if I'm going to do 200%, that's really a multiplier of times 2. My 6 will turn into, am I going to have enough space here? 1, 2, 3, 4, 5. Okay, I have barely enough space. Right, my 3 becomes 6. My 6 becomes, 12. 1, 2, 3, 4, 5, 6. My 3 becomes 6. 1, 2, 3, 4, 5, 6. My top 1 becomes 2. Every piece, right, guys? The trap door is like we might forget about a piece, and then our shape won't look right. And then, should I be counting this diagonal? No. Just use your ruler, because diagonals are complicated. My ruler does have a chip in it. That's why I use it, not you guys. Because I know it will annoy you, and I can just avoid it. Now, funny enough, when we scale it up to our 200%, and you might want to label this, 200%, and you could label your itty-bitty 50%. It actually hits a dot. A dot on the diagonal, right? Questions? So, those of you that are enjoying drawing on dot paper, there's also isometric dot paper that lets you draw in 3 dimensions. So as we get deeper in the year, I'll print more of these things and make them available at the back of the room. But yeah, dot paper, our regular dot paper that we're using is the same thing as graph paper. It just lets us see our shapes a bit easier, right? As opposed to drawing on graph paper, which we would have to draw kind of heavy or use colors. Dot paper lets us see our shapes a bit easier. Our shapes. Caleb? Yeah, like isometric paper, I could draw a cube on it. So here, check this out. So if I have isometric paper, just real quick, because math is cool. So if I do right, you can like start to draw like cubes and things like that. So like isometric paper, you could also, anyone ever play Cubert? The little dude that jumps, like you can make the Cubert math on isometric paper. Like you can do a lot with isometric paper. It's very cool. All right, so that was 4-3. So now let's check. In 4-4, I know my screen's not changing. In 4-4, we're gonna check. Is it still Karen? I forget who we're helping now. Sure, we'll say no, Patty. Patty, like my neighbor that I was helping last night. Patty thinks that these shapes are similar. And, I don't know, think of a Patty and Patrick. Patrick says they are not. So we need to defend whether these shapes are similar or are not similar. And if you need a reminder, look at your math notes, right, that I handed out, that we highlighted, that we looked at. How do we check if shapes are... There's a blank on your paper. There's a blank on your paper that I think we said, I gave you an alternative word instead of copy. And Katniss volunteers as tribute. Yeah, you shouting that out is the same as me like ruining a book for somebody. So my suggestion in those parentheses would be new over original, but if you want to write copy over original, that is up to you. What we are checking is those ratios of corresponding sides. Our corresponding sides. So time for random cards. We haven't gotten anybody involved yet. Well, just not through cards. They don't look the same. Don't trust your eyes. No, I like what you said. Like, don't back down. I like what you said, but don't trust your eyes. Trust the math. Okay, so like, even if two shapes don't look similar, do the math, check. Even if two shapes look like they're similar, do the math and check. Thank you, Gage. So, Caleb, what would you set up for A? Like, what would you start checking? So Caleb automatically says, oh, look at that, 2 to 4. That is times 2. So essentially, now I'm going to do this a tiny bit different, but it's really the same thing Caleb did. Caleb said check for times 2. I'm going to check for do I get 2 out of division, right? I think what Caleb's doing is saying times 2 gets 8, but I'm doing do I get 2 by doing 8 divided by 4, and that's just, I'm just checking, right? Boom, sweet. What about on the bottom, 8 divided, wait, we just did that. What about 5.6 divided by 2.8? And guys, this should be written on your paper because this is exactly what you're going to practice at home. So if you're not doing this right now, you're not going to know what to do during practice. If you didn't try this before I started going over it, you're acting like a baby bird. Quit waiting for somebody to vomit some food into your mouth. Yeah, that's what baby birds do. And it's gross, because you're not one. When I ask you to try a problem, you should be trying that problem. Straight up, I'm getting a little tired of people coming to me for help when I know they just straight up did not engage in class. I saw them. They were doodling, They were drawing on themselves. They were talking with each other. They went to the bathroom for 10 minutes. You cannot act like a victim when you do it to yourself. So if you don't engage in class and then you don't know what's going on, that's on you. I will still help you, but I will give you a little dose of honesty while I'm doing it. What about the remaining 4 and 2? Oh yeah, we already did that same thing. Try B. You if you choose not to, that's your choice, but I guess I could also choose to not help you on your homework. That'd be the wrong choice. I don't think I'll make that choice, but I would if I was. But you can do it if it makes sense in your brain to check for multiplication, whatever makes sense in your brain. Because both ways work, right? I think Caleb's way of doing times 2 worked out for him, and I think my way of checking the division worked out. I don't, but you can't always avoid things you don't like. I don't like going to the dentist, but I do it twice a year. Actually, I take that back. I kind of do like it now. I kind of do like it now. Why? Doesn't your teeth feel clean?
I just think it's a good thing. But the dentist feels smells and it's strong.
What is 36? We're actually starting copying the original 18 over 36. What do you start with smaller numbers? What does 18 over 36 also copy? So start right now with a couple of those examples, and then what we're looking for is every single pair has to make that happen. If one of the pairs goofs it up, it's over. Right? It just is. It's over. One of these things is not like the other. One of these things is just not the same. You're good to work on practice if you've got this done. Gauge. What do you think about B? Are they similar? Why? So I'll get back to that, but talk me through what else you had done. Okay, you want to move on to somebody else? Sammy, no joke, that actually happened. Yeah, sorry, I highlighted the wrong thing first, but Sammy said, so 18 to 36. Now be careful, is this really times, okay, kind of, but really what are they multiplying by here? Half. Because they're going, guys, I know, some of you are like, that's dumb, it's the same thing. They're going this direction, they're doing times half, right? But what Gage said, this is that times half? No. So what you could write down is 36 divided by 19 does not equal a half. So these are not similar. Crap, 30. My bad. Yeah, 30. 30 over. Sorry. 30 over 19. Now, if Patty said, well, we can fix this by tweaking one number, how could we fix these and make them similar, Bianca? Change 19 into 15, or, that would totally work, or change 30 into 38, right? If we made this one 38, that would be a times 2 or a 1/2, right? That's all the time we got. Time for lunch. Have a wonderful day. Clip your notes, clip your 411, clip everything. Liam, it's a bad idea to leave that stuff like that. I got people coming in here for math lunch and game lunch, and that is a bad idea. I don't even care if you're coming back here for games or not. Clip your stuff right now. Clip your stuff
right now. Flip your stuff right now.